Crash Course Instrumentation, Episode 12, Voltage versus Current Sources. Welcome back to Crash Course Instrumentation. In this episode, we're comparing two kinds of energy sources that show up everywhere in electronics and control systems, the voltage source and the current source. At first glance, they might seem similar, but understanding how they behave and how to apply them can make or break your system design. Let's break it down. What is a voltage source? A voltage source is a device or component that tries to maintain a constant voltage across its terminals, no matter what you connect to it, within its rated limits, of course. Examples: power supplies, 12-volt DC, 24-volt DC. Batteries, benchtop lab supplies. A good voltage source says, I will keep this potential difference steady, even if you draw more or less current. But remember, if you short it, current will spike. So while the voltage tries to stay fixed, the current can change a lot, depending on the load. This is why many voltage sources include current-limiting protection, like fuses, breakers, or foldback circuits. In real life, no source is perfect. Every voltage source has some internal resistance, called source impedance, which affects how well it can maintain that constant voltage under different loads. What is a current source? A current source, on the other hand, tries to maintain a constant flow of current, no matter what the voltage across the load turns out to be. Examples: 4 to 20, milliamp analog signal loops, current loop calibrators, LED biasing circuits, lab-grade constant current supplies. A current source says, you get this much flow, no matter what. This makes current sources very useful in long-distance sensor loops where voltage might drop due to wire resistance, but you still want an accurate reading. Some current sources are active, using transistors or op-amps, and some are passive, like a current-limiting resistor in series with a voltage source. You can even build a decent current source using an op-amp, a reference voltage, and a transistor, a popular technique in analog instrumentation. Comparing the two, let's put them head-to-head. A voltage source will change its current to keep the voltage steady. A current source will change its voltage to keep the current steady. Think of a voltage source as a water pump that pushes water at a fixed pressure. A current source is more like a pump that delivers a fixed flow rate, no matter what it has to push against. Important: in a theoretical world, an ideal current source could provide infinite voltage. In real circuits, every current source has a compliance voltage, the max voltage it can reach while maintaining the set current. If your load requires more voltage than that, the source can't keep up, and the current drops. Field examples: if you're powering a PLC input or transmitter from a 24-volt DC supply, that's a voltage source. If you're reading a 420 milliamp signal from a pressure sensor, that's a current source. When troubleshooting signal loops, if you see fluctuating current on a loop that's supposed to be constant, that's a red flag something's wrong with the source or the load. Fun fact: most sensors don't produce a signal on their own. They modulate an existing source. In 420 mA loops, the sensor controls the current, but the power comes from a loop supply or analog input card. Why it matters. Understanding the difference between voltage and current sources helps you. Choose the right signal type for your application. Protect sensitive devices from overload. Size resistors, load banks, and power supplies correctly. Interpret multimeter readings accurately. Design feedback systems that don't oscillate or self-destruct. Confusing these two can lead to circuit damage, incorrect readings, or fried components. That smoke is expensive, don't let it out! You might also see both used together. A current source drives a known current, and the resulting voltage across a load is measured. This is common in resistive sensor measurements, like RTDs or strain gauges. Quick tech tip: when in doubt, measure voltage across components. Measure current in series with the load. Be careful. Use non-contacting amp probes whenever possible. Check the datasheet of your signal source, especially in analog systems. Look for output type, voltage or current, range and limits, source impedance or compliance voltage. Thanks for watching Crash Course Instrumentation. Be sure to subscribe, check out the ModEL PDF on Source and Load, and join our Facebook group to keep learning. See you in episode 13.